Hi, today we are going to learn about structs in C++. I think it's one of the very important topics in C++, and it is really good for you for your interviews as well. So first, if we describe or know the difference between struct and classes, is that in struct, every member or data attributes are public by default, whereas in classes, everything is private by default. That's the only difference between struct and classes. Why use struct over classes then? Why not just like learn classes? Because structs are lightweight and yeah. So if we start from the basic definition, so right. Okay, so this is the basic declaration and usage of struct. Okay, so I'm defining a struct here by the name of point, and I'm gonna give it two values or like two data attributes. All right, now we have a struct here with two data attributes. Now there are like several ways we can make a struct object. So for example, we can have a why I'm not getting suggestions. Yeah, all right. So we're gonna define our object using this struct. Let's say this, and now there are several ways of making an object using struct. So in this way, we just define an object, but this is an uninitialized object because we haven't given it any parameters to define these member functions. So for example, if we like do something like p1.x. So what are we gonna get is the garbage value because it is just getting the previous value from the previous program or whatever there is at that memory location at this point. So if you like run it, so this is the garbage value that we are getting. So in this way we are just like defining an uninitialized object and over here now if we do this struct point p2 is equal to okay, now this is an aggregate initialization, so it's like similar to is for example first let me like run it. So p2, now we are gonna get x. All right, so this is similar to doing like this. If we just struct point p3, if we just like to p3 dot x is equal to 3, is similar to this as well. This is just a better way. This aggregate initialization, this is introduced in C++ 11, sorry 17. So this is a modern C++, should say, and this should also give us 3. Yeah, and there's also uniform initialization. For that, you just like let me comment this out. For that, you could actually remove this equal sign and now p2 I think this is the right format actually. Okay, let's see if it's working. Yeah, so this is uniform initialization. This is another way you could implement an struct object and give it its values. So this is just a basic declaration of struct. Now we can also use constructors with struct. So if you could just like implement something like point this right. So we just define our constructor. This is our default constructor, and this might be a weird syntax if you haven't used it. Uh, so if I mean it's just like similar to this actually. If I just like show you, yeah, like this. So these are similar, but this is the most more efficient way of defining your constructor. And yeah, and this is actually called initializer list. This pattern, if you define your constructor in this pattern, this part is actually called initializer list, and this is preferred over this format because you just define your member attributes before your actual constructor runs. I mean, obviously constructor is running, but anything, I mean, usually you define your member attributes inside this curly box, but over here you are just like defining, you are initializing it before that, so it's a better way. So you could just like use that. Actually, it's preferred in interviews as well. And we can also use this type of constructor with parameters, and that is called parameterized constructor. So if we just do an x and y column x, okay, this was supposed to be x, and x comma y this. So basically left side represents our member function or member attribute, and right side is the parameter that we are getting from here, and this is gonna define or initialize our member attributes as well. So if we implement it, like use it, so we can actually just use point p1. Okay, so in this way, we are calling our default constructor. So basically, we are using two types of constructor. If we are gonna pass the parameters, then this one is gonna be again gonna get called. If we are not passing anything, then our default constructor is gonna get called. So if we just like do p1.x, now we should get 0. All right, so issue was that our constructor name should be equal to our structs name, and also we should have a comma here instead of colon. So if we run it now, so yeah, 0 is printing because this constructor is being called. And now if we just like pass some kind of parameters here, let's say we pass 5,2, and now we should get 5 printed out. Let's see. Yeah, so now 5 is being printed. Yeah, so there's also for this it's more efficient using this type of constructor. Again, this is a parameterized constructor, and also you need to like use it for constant members. So if one of our members is constant, we have like use const, for example, like this. Now we cannot just like implement, we cannot just like initialize x to any value using our simple constructor where we define x equal to anything over here. We have to use parameterized constructor for this kind of initialization. So if we just remove it, right, now we can also use methods in our struct. So for example, let's say we have a method here, double distance to we have it is taking an object by reference of type point as well. So for example, point other const. All right, so this keyword is like very, you could say, likable in an interview. So it just means that this method is not gonna like affect our member function, or it's not gonna change anything in the function. It's just a read method, so it's gonna return something. It's not gonna modify anything. So we can just like do dx is equal to our x minus other dot x, and we could just like return dx, I guess. Yeah. Now in this way, so all right, our x is gonna be 5, and now if we make another point, if we make an other object, just let's say 1, 2, and we do count p1 dot, I don't know why I'm not getting any suggestions. Distance to, then we could just like give it p2 as our parameter. We are giving it as reference, so it just means that other is another name for the same memory address where p2 is defined. So we know that p2 reference to a contiguous memory block in stack. So other just means that this symbol, this is a reference symbol, so it just means that other is gonna represent the same memory inside the stack. So we are not taking it, we are not like copying that memory in the other object's memory, because that would not be a very efficient approach for our memory allocation. All right, so this is gonna, all right, so if we run it, so we are getting 4. So this is a way of using methods with our struct. Now if we could like also use inheritance, polymorphism, data abstraction, data encapsulation with structs as we do in classes, but I could actually use that in another video if you wanna see that as well. But for right now, this is like a basic level of structure of using structs. I have like used constructor, methods. So I guess you now have a like solid understanding of structs. Actually, if we also talk about memory layout and padding in struct, so we know that our compiler add padding in our data members or like over here. So, and why I do it? Because it's easy for our CPU to extract the data from the memory if it's properly aligned after like 4 or 8 bytes. So let's say if we have, let's say we have char A. So char A is going to be 1 byte. Then our compiler is going to add 3 bytes of padding in front of char A. So that's going to be like 4 bytes, 4 bytes, 4 bytes. So that's going to be 12 bytes of like total memory layout for this struct. But if we do like this, and actually let me just char B. Yeah. So over here, if I tell you again, our char A is going to be 1 byte, this is going to be 4 bytes, and this is again is going to be 1 byte. But after adding padding, so char A 1 byte, then we add 3 bytes of padding, that's going to be 4 bytes, then 4 bytes for int y, 8 bytes, then 1 byte for char A, but again we are going to add 3 bytes of padding after char A, after that 1 byte of original value. So that's going to be like 12 bytes total. but it's more efficient. You could actually reduce your memory usage if you put the biggest or like yeah biggest memory allocator first. Over here it's integer, it's consuming like 4 bytes of memory. So now if you see, this is gonna be 4 bytes, all right, and this is gonna be 1 byte, and again this is going to be 1 byte. Now we don't need to add 3 bytes right after this char b, because we already have 4 bytes. First we have allocated 4 bytes, so we don't have to like allocate 3 bytes after this char b, if that is making sense. um, but after char A, we will add 2 bytes. So this is going to be 4 bytes, and these two combined is going to be 2 bytes. And after these 2 bytes, we can actually add another 2 bytes for padding. So that's going to be 8 byte total. So I'm just like trying to tell you that you could actually reduce your memory usage if you just like rearrange your data member and put the biggest memory consumer first and least afterwards. So that's another way of using memory layout. So yeah, I think pretty much that's it for structs. If you wanna see another video on structs, just comment below.